Hi, I'm Pat Scandalis from Moforte Inc. This video will show you how to compile and run Faust algorithms on the Analog Devices SHARC Audio Module. Here's where we're going. A classic virtual analog synthesizer plus effects chain running on the SHARC Audio Module. Here is an overview of the topics that this video will cover. The SHARC Audio Module and the Audio Project FIN. Installing Faust on a Mac or Linux machine. Installing CCES, the Analog Devices toolchain, on your PC. Installing the bare metal framework wizard and using it for Faust development. Using Faust to SAM or the online Faust editor to compile algorithms into C++. Copying the Faust C++ output into a project using the bare metal framework. Compiling and debugging the project with CCES. Booting the SHARC Audio Module with no debugger. Using the touchOSC interface. And a few other examples. This is the SHARC Audio Module. Here we have the Griffin part, which is a dual-core SHARC chip. And there's various types of I/O, most notably line in and line out. And then here we have the ICE 2000 or in-circuit emulator, which is used to send code directly to the cores in the SHARC from CCES, which is the cross-core embedded studio that Analog Devices provides for developing code for this. On the flip side, we have the Audio Project FIN, which provides a number of different types of I/O. We have quarter-inch audio stereo in and out. We have conventional MIDI DIN in, out, and through. And there are a number of switches which are mapped to MIDI continuous controllers. And there's a couple pots which are also mapped to MIDI continuous controllers. In the bare metal framework, here are the default MIDI mappings for the pots and switches on the Audio Project FIN. These defaults can be modified by editing the Audio Framework Faust extension for both Core 1 and Core 2. The following commands can be used to clone, compile, and install Faust on either a Mac or a Linux machine. Let's take a quick look at the Faust installation. In the Faust installation, you'll find a directory called Examples. And then within Examples, you'll find a directory called SAM, which contains a number of different examples that can be run on the SHARC Audio Module. Here's a document that describes how to use the Faust to SAM tool to integrate with the SHARC Audio Module. The toolchain provided by Analog Devices for compiling code onto the SHARC Audio Module is called CCES. If you go to Google and search on CCES Analog Devices, you'll be able to find a reference to the CCES toolset. If you click on Downloads and Related Software, you'll find a link to download the latest version of CCES. If you go to wiki.analog.com, there's a wiki page about Faust integration. If you go here and you search on Faust, you'll find an entry for Faust integration with the SHARC Audio Module. And if you take a look at that, there's some very good documentation here provided by Analog Devices, which is based on the document that is in the Faust installation. However, there's additional information like where to get the bare metal framework to use with the Analog Devices toolchain. Downloading and running the bare metal framework installer will add the bare metal framework wizard to your copy of CCES. We'll come back to this wizard when we look at setting up a project in CCES. The Faust to SAM command is a part of the Faust installation and is used to convert your Faust algorithm into 3 C++ files that can be dropped into Analog Devices' bare metal framework for the SAM board. Alternatively, you can use the Faust online editor to generate these 3 C++ files. Drag the DSP file into the drop zone for the editor. You can try the algorithm with the play button.
Reverb.
The export button with the SAM drop-down option is used to export the 3 C++ files for the SHARC Audio Module. This diagram shows a typical workflow. The algorithm is initially designed and evaluated on a desktop computer. The algorithm can be evaluated either with the online Faust editor or with a native code Faust compile using a tool like Faust to CAQT. When the algorithm designer is ready to migrate the algorithm to the SHARC Audio Module, the Faust to SAM command can be used to generate the 3 C++ files that can be imported into CCES. This block diagram is a high-level representation of how data flows through the system. On the SHARC Audio Module, the Griffin part is a dual-core DSP. Core number 1 is running the virtualAnalog synthesizer using about 8% of the CPU. It receives audio buffers from the codec and passes audio buffers on to core number 2. Core number 2 is running the effects chain using about 12% of the CPU. It receives audio buffers from core number 1 and passes audio buffers on to the codec. Finally, the audio project FIN board has a UART that is receiving MIDI bytes. These MIDI bytes are passed on to core number 1, and core number 1 also forwards them to core number 2. Now let's use Faust to SAM to convert the Faust algorithms for the virtualAnalog synthesizer and the effects chain into the C++ files that can be inserted into the CCES project. Faust to SAM for the virtualAnalog synthesizer uses both the -MIDI and the -invoices argument. Faust to SAM for the effects chain only uses the -MIDI argument because it doesn't have any voices that need to be allocated. When we get to CCES, we'll see that there's a separate subproject for each core, and each core has a Faust directory where we can place the C++ Faust files. Let's take a look at how to set up CCES. What I have here is I have the virtualAnalog, which I generated on my Mac using Faust to SAM, and I have the effects chain, which I generated on my Mac using Faust to SAM. And I'm going to set up a new directory here called virtualAnalog effects in my working directory that I use for CCES. And let's go ahead and start up CCES. So the very first thing I'm going to do is I'm going to launch it. And it's going to ask me what directory I want to set up my project in, and I'm going to set it up here in this directory, virtualAnalog effects. There's nothing in that directory, but that's where I'm going to set it up. I'll go ahead and launch CCES. Okay, so I'm going to close this initial help here, and what I'm going to do is go File, New, SHARC Audio Module, Bare Metal Project. I'll go ahead and do that, and I'm going to call my project name virtualAnalog effects. Okay, and then I'm going to hit next here, and it's going to ask me some interesting questions. Yes, I'm using the audio project FIN for both audio in and MIDI, and I'm not using the A to B modules, and I am running Faust on both core 1 and core 2. And that looks like a good block size to me, 32 samples, and that looks like a good sample rate, 48K. And I'll go ahead and finish this. And what it's going to do is create a template bare metal project for me to work with to set things up. There's the template bare metal project. Now there's something to notice, is there's actually 3 different subprojects in here, one for each core. So there's a project for core 0, a project for core 1, and a project for core 2. Core 0 is the ARM core, core 1 is the first SHARC core, and core 2 is the second SHARC core. And if you look here in the source directory, you'll see that there's a directory here called Faust, which just has a bunch of placeholder algorithm files right now. So what I'm going to do is I'm going to go out here to the file system, and I'm going to start out with virtualAnalog. I'm going to grab my 3 files, and I'm going to go over here to my virtualAnalog effects project. I'm going to go to virtualAnalog effects. I'm going to go to core 1 source Faust, and I'm going to copy in the 3 files. And now I'm going to do the same for the effects. And here I'm going to go up here to core 2. And if we take a look at source and Faust. I'm going to copy in those 3 files into the Faust directory. Let's just take a look at something here briefly now. So now I have the project set up here, and I no longer need these, and I'm going to close that out as well, and we can just focus on the project. So the first thing that I'm going to do is look at the build configurations for each of these. And build configurations, it's debug for that one, it's debug for that one, and it's debug for that one. I find it easiest to build both the debug and the release versions of the project so that I can switch between the two. Now that the template project is set up, we want to make sure that it can compile incrementally. The way that we'll configure this is by going to each subproject, and we're going to go here to Properties, and then we're going to go to C++ Build, and we're going to go to Refresh Policy, and the template put in a refresh policy for something called SAM Bare Metal Framework Core 0. We want to actually delete that, and we're going to add a resource, in this case for Core 0. We'll hit OK, and we'll apply and close. And then we're going to do the same thing for Core 1, Properties. I'm going to delete that. I'm going to add a resource, and in this case it's Core 1, so I'm going to add the Core 1 resource, and I'm going to go apply and close. And I'm going to do the same thing for Core 2, Properties. I'm going to delete what the template put in there, and I'm going to add a resource for Core 2. I'll go OK, and apply and close. Good, and now we should be set up so that we can do incremental compiles. You'll want to do the same steps for the release configurations as well. So I'm going to go ahead now and go to Project, Clean, and build the whole thing. And this is going to take about 4 minutes to build. The debug compile is completed. Let's go ahead and change the build configuration. So I'm going to go here to Build Configurations, set Active to Release, Build Configuration, set Active to Release, Build Configuration, set Active to Release. There we go. Okay, we're going to go ahead and compile it again. Project, Clean, and we'll be back again in about 4 minutes. While this is compiling, let's take a look at the bench setup. So we have the SHARC Audio Module here, and it's connected to power. I'll power it up, and this little LED, green LED, will turn on. We have audio out coming out, going into a speaker, which is back here. And then we have the ICE 2000, which is plugged into this little connector right here. And then a very important issue here is there is a jumper down here, which I just store on the bottom. And if it's in the bottom position, if it's not connected to anything, what that means is that CCES can send code to the SHARC and download code into the SHARC. If you have successfully gotten an algorithm to run on the SHARC Audio Module, then you can move this jumper to this position, which is pins the lower one and the middle one, and then you can power it off and power it back on, and it will boot into being the algorithm that you last were debugging on the device. Let's look at the other side. The audio project fin. What we have on the back here is we have the MIDI connectors, the audio connectors, and the buttons, which are mapped to specific MIDI connections. I'm going to turn on my MIDI controller right now, and you'll see that this little MIDI in LED blinks when MIDI messages are coming in. So we're ready to start debugging. So in order to debug, we're going to have to set up a debug configuration. So debugging happens with this little bug up here. I'm going to go ahead and click on that. It's going to take me through a little wizard. You want to choose the chip that the processor family you're using is the 589, so you're going to select that and go next. You're using an emulator, which is the ICE. I happen to be using an ICE 2000, but if you use an ICE 1000, you should choose that. I'm going to choose the ICE 2000, and I'm going to go finish. Okay, great. Now let's make this a little bit bigger. What we need to do now is assign the various binaries to be used in debugging, and it says click here to select a program to load, and there's one of those little notices for device 0 or Core 0 device. It all says device 0, Core 0, Core 1, and Core 2. So I'm going to start with Core 0, and I'm going to browse into the project, and virtualAnalog affects Core 0, and then I'm going to search the project, and I'm going to choose, in this case, the release build. I'll hit OK on that. and I'll hit OK on that. And now I'm going to go to Core 1, click here, Browse. I'm going to choose virtualAnalog Effects Core 1, and I'm going to search the project, and I'm going to choose the release build. I'll hit OK, and I'm going to do this for the last one, Browse, virtualAnalog Effects Core 2, and search the project, and I'm going to choose the release build. OK. OK. Okay, I've assigned all the binaries for debugging right now, and so I'm just going to give another. Actually, I like this name, but I'm going to call it virtualAnalog Effects Release. And I'm going to go ahead and apply this right here, and we'll be able to use this debug configuration in the future. So it's good that we set it up. I'm going to hit debug here, and I'm going to have it remember my decision. Okay, so we're ready to start debugging. So let's take a look at the bench setup for just a second. So you see what happened here over on the ICE 2000 is that the LED is now blinking sort of blue-red. It's a purplish color. That means that the debugger is in communication with the Griffin chip. And if we go over here and look at the debugger window, we see that for each of the cores, Core 0, Core 1, Core 2, there is a line entry. And what we're going to do is we're going to start each core separately, and then everything should be running. So the first thing I'm going to do here is I'm going to select the automatic breakpoint that's on Core 0, and I'm going to hit the play button here to start it running. And then I'm going to go to Core 1 and start that. And now I'm going to go to Core 2 and start that. If you take a look over here now on the bench setup, we got blinky lights. That's a sign for us that the DSP code is running on the Griffin part right now. So let's just give this a quick test. I have the speaker turned on, I've got the MIDI controller turned on, and let's just try it and see what it does. That's beautiful. Finally, let's look at how to get the SHARC Audio Module to boot to the algorithms that you load into it with CCES. Right now, this SHARC Audio Module is running the virtualAnalog synthesizer, and it's attached to CCES, but what I'd like to do is set it up so that it can boot to those algorithms. So what I'm going to do is I'm going to go back to this jumper here. Right now it's just hanging off the bottom pin, and if I put this jumper between the bottom and the middle pin and put it in place, and now I've detached the SHARC Audio Module from the debugger, and I'm going to power it up. And you can see from the blinky lights that it's booted up to the virtualAnalog synthesizer. So here I have the SHARC Audio Module. It's been programmed to be the Minimoog and the effects chain. I did put on the special jumper after I programmed it, so that it will boot to being the Minimoog plus the effects chain, so I can just power it off and power it back on to reboot it. I happen to be using a Bluetooth interface because it's just easier for me to connect to an iPad with a Bluetooth interface, no wires in between the two. And then over here we have touchOSC, and it's set up with the same layout that you saw in the Minimoog. Here's the oscillators, here's the mixer, here's the filter, and the two envelope generators. It's pretty much the same thing. And then over here are all the effects. There's a flanger, there's a chorus, there's an echo and a reverb. And you can access all of these things from this touchOSC interface. A couple of the things that I like to do is to go to the effects chain. I like to turn on the chorus. There it is with chorus. And let's give it a little reverb too. And I also turn on the glide so you get this classic analog synthesizer sound. I'm going to do a brief performance. So the first thing I'm going to do is turn on the chorus to thicken the timbre of the sound. And then I'm going to turn on the reverb to place the sound in a space. And finally, I'm going to turn on the echo. But you'll notice there's only one echo, so what I'm going to do is turn the feedback up all the way so that it regenerates infinitely. That way I can create a short loop that I can play on top of. Let's go ahead and do this. Very nice. Now I'm going to turn off the echo to lock in that loop. and I'm going to go back to the main synthesizer, and I'm going to play something. And then finally, we'll go let the echo go off on its own. And it's booting up to a flanger, so it's a stomp box. The buttons and the knobs are wired up, and I'll show that in just a second. But I'm going to play it dry first for just a second. And now I'm going to turn on the flanger. We had the echo box here running as a standalone bootable stomp box, and I'll just play it for a second. So here we have the bootable chorus stomp box, and I'll just play it dry at first so you can hear what it sounds like. And I'll go ahead and switch it on. That's a big sound. This is the reverb. It's Freeverb. It's a shorter reverb. It's a very nice reverb. I'll play it dry first. And now I'll turn it on. And let's turn up the dampening a bit. Here's the full effects chain. Each one of the buttons corresponds to a different effect. This is reverb, this is chorus, this is flange, and this is echo. And I'll just play one chord so you can hear each of these. This is dry. This is with the reverb. This is with the chorus. This is with the flanger. And this is with the echo. Here is a SHARC Audio Module with a DIY board. It's not connected to an emulator. It's only connected to power, audio in, audio out, and then there's a MIDI connection. It's set up to boot to the virtualAnalog synthesizer. So we're going to go power it up here, and I'll just play a couple notes.